This release includes a powerful new parametric selection tool named Query Variable. It allows you to dynamically define what selections are used in downstream features. In this video, we'll look at a few basic examples. This board with pegs through it was defined with a few simple features. A design sketch contains all possible locations for the pegs, and the user has selected their desired locations within the extrude tool. A Boolean subtraction was used to create the cuts through the main board. And finally, a hole was placed through the center of each peg, once again based on a user selection from the design sketch, and an appropriately selected merge scope. The problem with design intent occurs when trying to add additional pegs. The user edits the extrude feature and adds the additional selections, but notice that neither the Boolean nor the hole feature are included in the new pegs. This is because the downstream features were defined based only on the parts that existed at the time they were created, so we'd need to edit those features and add the new parts to their scope. Instead, we'll now solve this using query variables. Rolling back above the extrude, we'll define a new query variable, which we'll name design. Query variables support a variety of options. In this case, we are simply picking selections for where we'd like the pegs defined. Notice that we pick both the face and the vertex for each selection. This will be important in a later step. We'll then edit our extrude feature, and rather than utilizing manual selections, we'll instead use that query variable as the input. Notice a peg is correctly extruded at each location we selected in the design query variable. We'll define one more query variable at this point, which I'll name pegs. Instead of using selections, I'll choose the selection type of created by, select extrude 1, and change the entity type to body. This query variable is now parametrically gathering all individual bodies that are created as a result of the extrude 1 feature, the pegs. This is exactly the geometry that we will need to define as our tool bodies for our next Boolean operation. Finally, we'll update the hole feature. The merge scope will be our query variable defining the pegs. The locations will be the query variable for design. Notice that even though our query variable design contains both sketch faces and vertices, when applied in a dialog, the query variable automatically filters out any invalid selections, in this case passing along only the vertices to the feature itself. Our model is now correctly defined using parametric selections through these query variables. Changing the design variable to include additional peg locations causes all downstream features to rebuild as we would hope, with no further cleanup required. This is just one basic example of how query variables can be used. Exploring them further, you'll find there are a large number of selection types available, and each selection type has different filters for entity type. The use cases for query variables are far-reaching, as you can even define additional queries within a single variable to further filter your selections. For more information, we strongly encourage you to review the help documentation.
The trim tool in Onshape drawings makes it easy to clean up excess geometry. Select a line or curve, and it will trim back to the first intersecting point or bounding geometry in the drawing view. If no intersection is found, the entire entity is deleted. You can also remove points. This gives you precise control over drawing geometry, helping you create cleaner, more accurate views or drawing templates. Onshape now gives you more control over how cosmetic threads are displayed in your drawings. In the All Views section of the Drawing Properties panel, you'll find a new set of thread style options. Choose between ANSI, ISO, and JIS, ensuring your drawings match the standards required for your project. You can also adjust the appearance of threads, including color and line thickness, so they're easier to read and better aligned with your company's drawing templates. Onshape now makes it easier to manage revision callouts in your drawings. If revision callouts have been hidden and you try to add a new one, a blue notification appears at the top of the screen. This notification reminds you that callouts for this revision are currently hidden. To bring them back, simply right-click the revision row in the revision block and select Show Revision Callouts. All callouts for that revision will be displayed again. This update ensures you always know the status of your revision callouts, while keeping full control over when and how they appear in your drawings. Document Notes puts project context where you work. Inside any document, click the Document Notes icon to open a panel on the left. Inside any document, click the Notes tab to add text, markdown, and hyperlinks. Use Preview to check formatting. Choose Apply to save your notes or Cancel to discard. Use Refresh Notes anytime to pull the latest updates of other collaborators adding notes in the document. On the Documents page, when you select or search for a document, the same notes appear on the right. Typical uses involve pasting a checklist, links to requirements, or adding assembly build steps. Anything your extended team needs to see at a glance. That's Document Notes, fast shared context with rich formatting exactly where you need it. Onshape Cam Studio now makes it faster than ever to set up machining operations with new powerful selection tools. Imagine you're preparing a plate with hundreds of holes to be drilled. Instead of selecting each hole manually, you can now use progressive selection to quickly grab all blind or through holes in a part. From there, you can filter the selection even further, by diameter or depth, so only the holes that match your machining intent remain. This makes it easy to create toolpaths for large groups of similar features in just a few clicks. This release of Onshape includes a significant enhancement for PCB Studio, the addition of a full board and component feature tree for imported ECAD data. Whether the design comes directly from Onshape or from an external ECAD system, the feature tree now shows the key elements of your board in a structured, easy-to-navigate way. What you see in the tree depends on the ECAD format. For IDF format files or PCBs modeled in Onshape, you'll see the board, components, component instances, and keep-in-out areas. For IDX files, the tree also expands to include the board's layers, layer stackups, and defined regions. This improvement makes it easier to review, organize, and manage complex PCB designs, providing greater clarity and consistency when working across mechanical and electrical teams.